Okay, so what we are going to expect over here. So the previous reaction we saw was magnesium ribbon was burnt in the presence of oxygen to give rise to magnesium oxide, and then we took this magnesium oxide. Okay, mm, we are taking this magnesium oxide. Yeah, we are going to take this magnesium oxide. One molecule will take. We are mixing with water so that it becomes magnesium hydroxide. Okay, MgOH. This bracket should be a must. Okay, now then we checked this with a litmus paper and we saw these were both the chemical changes. These are both falling under the category of a chemical change. Okay, then ultimately we see using the litmus paper test when we are doing to check if it is an acid or a base, because the litmus paper is going to change a color, change its color. There is going to be a color change. Then what do we see here? Due to this color change, we are going to see that it is becoming a physical change as well. Okay, it is becoming a physical change is what we see here. Okay, now after this we are going to see another reaction wherein what they did is they took copper sulfate solution. Okay, second reaction that they're doing is copper sulfate solution, CuSO4. S and O both should be capital. Okay, in this copper sulfate solution, this copper sulfate solution is usually blue in color. It is copper sulfate solution. To this blue color solution they are adding a blade. Okay, it's blue in color, so they are adding a blade or a nail you can add. So blade will be like this, or if they are adding a nail it would be like this. Okay, they are adding a nail into this. Now this blade or this nail is made up of iron. Okay, it is made up of iron, right? Isn't it? Okay, it is made up of iron. Iron is denoted by Fe. Okay, so now there's a chemical change going to happen. Okay, Fe is a metal. Copper, which is Cu, is also a metal. Okay, and these are reactive metals. What type of metals are these? These are reactive metals. Highly reactive, or you can say very good reactive metals these are. Okay, so already Cu is with SO4. Now ferrous is reactive, so it what it does is it goes and combines with FeSO4. Fe is ferrous, iron is going to combine with sulfate. Okay, and then SO4 can take either copper or Fe. Okay, first copper was there, but because Fe wanted to take the place of copper replaced itself and it became FeSO4, and then left behind was copper alone. Then where will this copper go? In the liquid it will remain? No, it will deposit onto this metal, because देखो I have a blade is giving Fe, so it should take something, no? So Cu it is taking. CuSO4 was there, SO4 was having Cu, it is giving Cu and taking Fe, right? It is giving Cu and taking Fe. Okay, so this is how the reactions are taking place. Okay, so the solution, that CuSO4 that we had combined with FeSO4, sorry, my mistake, CuSO4 plus that metal blade, iron blade, gives rise to FeSO4, and Cu will be left behind on the blade. This is blue in color, ferrous sulfate is green in color, okay, and copper is brown in color. Okay, copper will be brown in color. These are the colors. So after the reaction, one chemical change is happening anyways in it. This type of a reaction where Cu was replaced, or Fe took its place, this is called as displacement reaction. What is it called as? It is called as displacement reaction. How is it called as a displacement reaction? Because Cu was displaced by Fe. Okay, okay, so displacement reaction is happening. Okay, now apart from the displacement reaction, you can see that there is some physical change happening too. physical change. What is happening? The liquid in the beaker, it was blue before, and after it became green, isn't it? It became green in color. Okay, the blade before was metallic in color. The blade was metallic in color. After this, it became brown. So physical changes are also happening when you see that the chemical change takes place. Whenever a chemical reaction takes place, okay. Now here they may ask you, what is a chemical reaction? Chemical reaction, when two or more chemicals combine, okay, chemicals, when they combine to give rise to the two or more chemicals combine to give rise to the product. Okay, this is called as a chemical reaction. So this is a chemical reaction. Okay, in a chemical reaction, chemical change as well as a physical change can be seen. Okay, and one topic we will hear here is that chemical changes chemical changes, most 99.9% of chemical changes are irreversible. They are irreversible. Okay, physical changes, if we talk about, usually physical changes are reversible. These are reversible in nature. Okay, so this is about another experiment that we can do to understand the physical and chemical changes. Okay.